Welcome. This is 1, 2, 3, part 1. We begin. All right. Apple Avalanche. So last time in class, we made that basketball game. It's working now. Replet's working. And you click that ball clicking and it did the score and so on, right? Boom. You can check this out. I had a timer on. Just want to play this because last time the video wasn't working. And then it'll tell me I got a gold medal. I don't know why it's doing that line. Oh, that's right. Because it reset the leaderboard. But there you go. I had it working. Now let's talk about Apple Avalanche. So in this game, it looks like you have a tree and there's going to be letters. There's going to be apples on this tree or other fruits. And they have a letter on that. The idea is that the user types the letter and then it falls from the tree. So this is a different type. Last time it was about the timer and then on click every time you click that spot. This time it's going to be about actually clicking, just typing on the keyboard, key presses. So different skill. So far you've achieved this. So that's the big thing we're doing here. Now what we're going to do, we got a few things to download. So if you look under step 1, there is a bunch of files, some apples and some backgrounds. We're going to go in here. We're going to download this. So you click on this, click download. You should get this zip file. Now, some people have issues with this. I don't know. I'm going to have to. Did I actually close Replit? Jeez, man. Okay. That was my old program. Let's talk about a new Replit. I'm going to make a new Replit, not right there. We're going to go into here. And then, oops, let's see it right here. Verify my email. I'll never do that. 1, 2, 3. Part 1 through step, I think I said 17. All right. So I've opened this up. Notice when I have this right here, this is my zip file. Now, if you don't know how to just extract things, usually I can just do this and drag over Replit, but these things are still zipped. So what you want to do is I can extract them right in here. This is one way. You know what? I don't like doing it that way. I'm just dragging them over to the desktop. So they're all on the desktop. I'm actually replacing these files because I've had them before. And then I click on my desktop here. You'd actually see them on the desktop. I'll sort by the date. So here's the 4 files. I'm going to drag them over. Boom. Now it's going to overwrite the main file already there. That's fine with me. So we have this apple, this pear, and this background image. And then the code right here. So I dragged it all in. Everything should be in here, right? Okay. So extract the files. We did this. Let's see, we run this file. So if we run it right now, and what's it going to do? It's going to put an apple in the middle of the screen. Okay. So you see that. All right. Image should be of the apple. Observe the source code and definition. It defines a function, draw apple, that takes an active apple parameter. What kind of object is active apple? All right. So we set this up. Let's look at this. So we import like as turtle at the start, as we always do. We set up an apple image with the name of a file. So guessing that's the file we use for the Apple image, right? And then we're going to start up our screen with the WN turtle screen, set up the size. Why is it doing the size like this? I don't know. I'm leaving it default. And then it adds this shape to the Apple images. If you don't remember, add shape, well, it basically makes, okay, it says makes the screen aware of this new file. So you need to do this because after you do this, load up a shape or load up this picture, then you can use it as your turtle. So I have to have this line to be able to change the shape of the turtle to that Apple image. So you have to do both. So remember to do that. That was tripping me up because I like add shape. What does that even mean? All right. But that's what it's for. You need both. Apple, setting apple as a new turtle. Okay, I'm calling it an apple. So that's this apple right here. And then it defines this function, but we're going to skip this right now because this is where you actively do stuff. It's going to call that function right here. So draws an apple, takes the active apple, changes the shape of the turtle to be that apple image. That's the command you use. You can make it actually look like a turtle, squares, all sorts of things, right? And then WN update. This thing updates the screen. So this might be used once in a while. Like what if I didn't have that? Would it even work? I'm wondering what it would do. It might need to do that to update the actual turtle on the screen. No, it doesn't look like it needs to. So I think that's just a good practice to make sure the screen updates because as you'll see, we're going to start adding other functions available. So there's other things that we can do that update's going to be important to run. So that's it. What is active apple? It is a turtle. Active apple at runtime, it'll be a turtle. Because that is, apples are turtles in this case. Now we're going to modify the code so that it uses the pair image instead. So how would you do that? Well, pair is pair.gif and apple is apple.gif or GIF. I don't know. Let's say GIF. Graph GIF. So it's going to be pair. And let's see what happens when we change it to pair. I'm going to wait and run it. And there, it's a pair now. Great. I'm going to change it back to apple because I want to be consistent. Well, that's how you can change it to use the other image, all right? Right there. That's the great thing when you have these setup variables that I know you use later in the code. A thing, like you could have just typed, you don't need to make this a variable. You could just type it right in here, type it right in here. But one of the things we make these variables for is that what if we need to use this and we want this to be consistent in multiple spots? What if we want to go from apple to pear? Well, then what if I had just put it in like this instead and didn't even have this line? I could do that, but again, I would have to remember to change all of these. And what if I forget to change all of them? Then we have a problem. Actually, I don't even know if that works. What did I just do? I just said undo. I just messed up things. So you don't want to do that. And oh, I can't even do this easily. Yeah, don't do that. That's why we have these variables in the setup area so we can create those things and make them work. All right, so I did that. Now create a scene with a tree of an apple on it. Okay, so we want to put that background in. What we do is we copy this line, bwn.bgpic, and then the background.gif, right? So there we go. There's our background picture. Might be like, well, why don't we just type it in right here when we made a variable for Apple images, right? Well, that's a good question. I think my argument is you only use it once. And so it's okay. If you only use it once, you don't need to make it a variable because that's just extra steps. But if this was something that maybe you changed a few times, or you changed the background depending on whatever's going on. Wow, this has been buggy like crazy all day for me. Okay, slow. There it goes. I don't know. Maybe Replic's being slow. I still think they want me to upgrade my account. Fat chance on that. All right, modify the code by defining and calling a function that causes the apple to fall or move to the ground. The following functions may be helpful. And they give you some hints here. So, and you can use some of these things. So we want to make it fall to the ground. So let's look at our picture. Now, where does this start off? Remember when you are doing this. Ooh. I want to annotate my screen like on Zoom. Do I have to actually start Zoom? Oh, man. I don't think it's going to bog it down too much. So there we go. Okay, so remember a few things on here. We have this like axis system. And on this, what's going to happen is we start, the default location is going to be at 0, 0, right here, right? And then what we want it to do is, and I think one thing to remember is that I think the bottom of the screen is about 180 or negative 180, right? And the top of the screens, it's about 180. Maybe it's like 200. And this is going to be same thing over here. It's going to be about 180. And then over here is going to be about negative 180. All right. Just a rough idea of what those spots are. It might be different on your screen, but I want to get it to the bottom right over here. I want this apple to fall this far. So to make it fall, I want the apple to move to about here. Where are we going to say that? Let's say that that's at about negative 150. I want to make it go down. And down on the y values, not the x values. So we're going to make a new function. And we're going to call it, I'm going to call it define, call it drop apple. Okay, so draw apple, I'm going to say drop apple. Why not? And I'm not going to put any parameters in there, okay? It's just going to take whatever. I almost could just do active apple in there. But watch, for now I'm going to say no. Because of other things later. So I want to take that apple, and we're still working with apple right here. So I want to say apple. I want it to drop. So how could you do this? There's a few different ways you could choose to do this. I would say some of you might use go to, some of you might use forward and things like that. So maybe I'll show you a few different ways. You can go to. I think that's what the default, if you know you got to go to a coordinate, that's I think my default way. I say go to, and you need the X and the Y value. Well, I want to stay the same X value, so 0, and I want to go to negative 150. Cool. So I should just do that. Let's see what happens. And it draws the apple, and then it's going to drop apple. Right? Let's see what happens. Oops. That takes forever. Replic's not being fast today. Oh well. It's been slow like this all day. Let's see what it does. All right, I moved over Trinket. I'm going to paste the code in Replit later. Sometimes Replit gets crazy, but it saves better than Trinket. So notice it went down, but one thing it did is it left that line, and I don't want to leave a line right like that. So I am going to change this to be apple.penup. Or you know what? We learned PU works for penup, because I don't want to draw that line. And there, it dropped down. Boom. Oh, so much faster than Replit. Thank you. All right, so it works. Okay, great. I'm going to clear all this stuff. And a few things. Be sure to consider how your code might need to change if we were to add multiple apples, all of which could start at different XY coordinates. So, okay, that works if it's 0, but like, what if you had an apple start like over here? It'd still be negative 150 on the Y, but the X values are going to be different. So this is where it gets different right here. What you can do, and they suggest in here, you can use the current X coordinate, Y coordinate, and that would work. So what I could actually do is go apple.xcore, and that'll get the current X coordinate and just save it. And so use that current one for the X position. So that would work out perfectly for me, because I always want to go to 150 no matter where it's at, but the X coordinate's going to be different. Now, another way you could do this. Apple, and they kind of give you a hint right in here. You could use like rotations and go forward if you want. Set X and set Y, I think, are a cleaner way. So I can actually go set Y to negative 150. Watch, instead of this line. So this is basically going to do the go to, but just do exactly what I want. There, sets the Y value. In fact, I'm going to leave my code like that. So I showed you both ways just so that you know there's more than one way to do this problem. There's no wrong way. This is probably the simplest way with the least amount of text. I think it looks the cleanest. So I'm going to go with that. But any way works. You could use like the rotations and going forward, whatever you want. Because the apple is a turtle, by default, it draws a line. Okay, we did that. Key presses. For your typing game to work, apples will fall from the tree whenever the user types the letter that was displayed. To do this, the program needs to detect the keys that the user presses. Being able to detect the keys a user presses is vital to providing additional interactivity between the user and the program. Let's explore how this works. Okay, so, here's an example program. So watch this, and you press the letter A, it displays an A on the screen. Cool. That's kind of neat. Now, awesome. So how does this work? Well, let's look at this. So we draws, okay, so it sets up a new turtle called drawer, defines this function, and then it's got this on Keypress, draw an A, and then A in quotes. And then it's got this list, and these are the key parts. I do have this all documented in this document right here. If you're following along, 2 of you anonymous people are in there right now. Maybe it's my students, maybe it's not. So I do have it in here. And the thing that we're learning is how to use on key press. So when a person presses a key, it's going to run this function. So the way on key press works is this sets it up so that when someone presses A, it runs this function, draw an A. And that's drawn right here. So it's going to set the drawer color to blue. and then writes an capital A with the font Arial 74 font bold, right? We want a different color like green. You can just green and set it in there. We did this. And then I hit an A, and it's A right now. It's green. Excellent. Other things here. So when you put a function in here, that's kind of like on time. I think on timer did the same thing, or on click. I think it did the same thing. This function can't have any parameters. So it's just got to be this function. And you also need this listen part. So the way this works is you can have a lot of different key press. Maybe there's multiple different key presses that you could press. And this listen will listen for any key press. So it's not just having this, like that kind of work with timer. You need this and this. So this listens for key presses. And as soon as, like, if you had multiple, like one thing is pressed, it goes. Another thing, I could have different letters in here. What if I had, so I could do the letter B. And you can't see my keyboard, but if I hit the letter B, and it'll work. What's neat is I can use actually spacebar. So what did I said space right there? And hit space. Hey, so I can change it to space. What about if I use the arrow keys? Let's say left. And this gives me an error message. The reason it does, and it gives me an error message, because if you want to use the left arrow key, it's got to be capital L. So here's a capital L. And I use the left arrow key, and it does that. Isn't that annoying? So for spacebar, spacebar worked when it was lowercase space, but if I did an uppercase space right here, it ain't gonna work. So you have some of these, I know, it's inconsistent capitalization. I'm sure there's a list somewhere, I don't know, but I'm sure every button on the keyboard is there somehow, but I don't know what all the commands are. But there you go. Spacebar might be used like a jump button in a lot of games and stuff. You do that. So I imagine you're going to be using that. The arrow keys might be used to move around. So there you go. All right. You need this listen part too. If you didn't have this listen, what happens? Watch it still works. And my space button. Nope, not working. All right. So you need to have that listen part in there. And that's why I noted that. Listen, you need to have this with on key press. All right. Modify your program to make the apple drop using the A key. Okay. So whenever I press the A key. So the great thing about this is I can just say, okay, well, let's copy this code into here. We put it in the function keys and drop apple. I want it to drop apple. And you press the A key. All right, so I'm going to run this now. Wait, I don't know. And then you got to take this off. It's going to drop right away, right? Did I mess that up? Okay, so then draw the apple. And then and I press A. Now, I have pressed A and nothing happens. Wait, I'm going to do this again. Because, okay, that worked. Right? There you go. Now, sometimes, watch this. Like, what if I clicked over here and I pressed the A key? Nothing's happening. You need to make sure after you hit play that your cursor or your is active over here. So like left click over here so it's on the screen, then hit A. Sometimes if you're not getting any reactions, it might be because you accidentally clicked down here or clicked over here. I had that issue, and if you do Replit, the default is the cursor stays in the terminal, so you have to click on the picture. So if that's not working, click on this picture. Boom. All right. Okay, so I made it work. Modify your program to make the apple drop when you press the A key. And now, 11, this is where it gets harder. So far, so good, right? Too bad, little modifications. Here we go. Harder, add a function in your code that draws a white letter A over the middle of your apple before it drops to indicate the users that they are supposed to type the letter A. Okay, so we're going to put an A in the middle of the apple. My assumption is that you're going to have different letters in the future, right? So it's kind of like, oh, what letter do I press? And it's supposed to type, and then or you could just add a function to the code that draws the letter white A on the top of your screen. That's lame. we're going to do this. I don't think this is much harder. All right. I mean, the question is, oh, now you got to make it draw where the apple is. And you're like, well, how do I do this? There's a note about it positioning, but you have to use the right function. You're like, what's the right function? And then you go, I mean, I said that too. And I go, wait a minute, right? And I go, I searched in my commands. Did we learn this before? Oh man, we did. It's right here. So we can write like this. Actually, you can just go back to this code. Here's the right function. Maybe I need both of these. So what I'm going to do is I'm going to go when it draws an apple, I want it to actually put the letter in there. So I'm going to do not drawer, it's active apple. I'll make the text white because I think it says that. I want you to write a letter A. And let's see what this looks like. Okay. It draws an A. And if I drop, it drops. The A stays up there. I want that A to be in the middle of the apple. So how do I make it stay in the middle of the apple? All right, so the A is in the middle of the screen. We don't want that A in the middle of the screen. And first of all, okay, I don't like that font so big, so I'm going to go down to 40. Done this before. I'm going to leave it bold. I don't care. Font, I don't care. I still want this centered. So I'm like, well, what can you do with font here? And this is where they say, oh, that's why it's hard, because you got to like look things up on what right does. So I don't know what right does, so I'm going to go to my commands and go, I have this turtle reference. I bet there's more to write. So I'm going to go control find and look for right. It's right there. Okay, a few things. So you have more arguments you can put up here. Okay, I have a line where I can say a line equals left, center, right. So maybe I want to do a center alignment. And it says right text, the string representing R at the current turtle position along with a line. So, okay. If move is true, the pen is moved to the bottom right corner of the text. By default, move is false. All right, I don't really understand move. Did this earlier. But I do understand alignment. I want to make it center. I think there's more than one way to do what I'm going to do. My choice is to make it centered first. Okay, it's centered. I wanted to lower it a little bit. Now, the way I would do this is I'm going to make the cursor dip down a little bit, draw the A, and then come back up. So, okay, I'm going to go active apple dot I want it to move down. So I want it to set the Y. Okay, so I'm going to do set Y. Watch me. I'm going to say take the current Y and then subtract, I don't know, 20. Let's guess. So I'm going to do active apple dot Y core and then minus 20. Let's see what this does. Okay, the problem is, oh, it moved the A, but it also left the apple down here. I want to move it after it draws back up. So active apple dot set. I want to take the set Y. I want to move it back up 20. So whatever I choose to move it down, let's move it back up. Okay. What was annoying is that it drew that. You know, I'm going to take this pen up. I'm going to put another pen up in here. I'm going to go active apple dot pen up. Right? Now, another thing you notice that, oh, well, I'm going to drop this down more. Say 30. You might notice that apple shifting, right? Okay, let's say it's centered enough, right? You might notice this apple shifting back up. You're like, oh, I don't want to see that movement. So there's a thing they teach you how to do is this tracer command. You may notice your apple bouncing around as you drew the letter A. To prevent this from happening, you can turn off tracing for the turtle's path that's shown below. Okay, this tripped me out a little bit, but I think I can explain this now. So oh, I know what was tripping me out. I couldn't figure out what was going on. So when you use this tracer command, I think I put tracer in here. Did I put tracer in there? Yep. Okay, a few behaviors of tracer. So I'm like, what? Okay, tracer basically when you turn it off, it's gonna do all the commands, but it's gonna leave it invisible. So watch. Oh wait. So what's gonna happen is you're not gonna see all these movements. Like imagine if this was all true. Right now. The problem is I don't think they set, oh, see? Look how it's drawing. Look how it's drawing, right? So I set them to the slowest speed. You can see it draw, right? Those 3 lines. But watch when I turn off tracer. So tracer means that it does tracing the lines. But what if you don't want those to happen? What if you just want it to instantly pew, 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 right? If I do this to false, then the first drawing, it's just instantly going to appear. So it's like it does this, and then it just does this drawing slowly. But if I do this one as false, it's going to go pew, pew. And then when it turns it back on, then it'll slowly do this one. And it's doing it slow because it changed the speed to 1, right? Now, oh, one thing. Okay. This was commented out if you tried this at home, because I think it still had that saved from the last time I used that. So watch what happens. What if these were all false and I didn't have this update? This is where we're going to learn why update's important. Nothing happens. You're like, what? So what ends up happening? This is where an update's important. It's doing the pew, 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 but it doesn't update the string or the screen until the screen does something. Like, because this was true, it's going to pew, pew. As soon as this turns true on, and then this starts drawing, then it does those updates that were kind of invisible, right? So that's where this WN update comes in. So it says, hey, you know, if you've done some things that you didn't trace, let's just run update. Sometimes that's not important. But in this case, it's important because otherwise you wouldn't see those lines. Like, what if I made this one true. So if I did this case, watch what happens. Yeah, instant line. Oh, and if I didn't comment this, let's say I didn't do this. In this case, you go instant line, it should draw this, and then this won't show because it's waiting for this update right here. So I spent a little time talking about this because I think it's important. The way it started off, I couldn't figure out. I kind of understood it, but those little, now I understand the importance of update in this case. So what I can do is I can make tracer false. So how does this help my apple? So when I'm about to draw, I can go, I should keep it close to when I actually draw and when I actually move. So I'm going to go tracer false, and I'm going to say tracer true. So what should happen in this case, you didn't see it move at all. There you go. I know it's super fast, but there you go. So if you want it to be not show all those little movements, that's one way to make it work. All right. Don't need that anymore. Moving on. You don't want fallen apples or random letters being left on the screen once the user makes the apple fall. Use the following commands. Okay, so we had this issue. Okay, now we're in here. We hit the A button. Oh, it left the A. I don't want that A to be there anymore, right? So one thing I can do is I can say apple.clear. This will clear all the drawing. So if I'm back in here and hit A, boom, apple's on the floor. Now, they also said, I don't want to show my apple. I kind of wanted to show my dead apple on the ground. You know what? Fine. I'm going to hide the turtle for now, but I'm going to change these rules later. I want to see dead apples if I'd feel better seeing more on the ground, you know. This is kind of like, you know, it's like a body count. Boom. I want to know how many apples I took out. Thank you. But let's see what I'm going to do. You know what? I'm going to leave that apple. Well, it's not going to work because I'm going to have a new apple. But, so, you know what? I'm leaving it on the ground. I don't care. I ain't touching it. I'm not going to do their world. Let's add randomness. To this point, you have been making small changes to the Apple Avalanche game. Typing game code. For the rest of the activity, you will work on larger portions on your own. This will require you to plan in advance and iterate in your design. Oh, great. Oh, let's just do a bunch of stuff at once. There'll be no problems with this. That's right, Project Lead the Way, huh? Previous activity, you've seen and used random integer to generate random numbers. If an apple falls from the tree, you'll need to reposition it to give it a new letter. So the apple's going to fall, and then you want to put it back on the tree and give it a new letter. Okay, so that's why we want to make it disappear. If you choose to correlate letters and apples earlier. Okay, well, I did. To help you keep your thoughts organized, the two to-do commands have outlined below. The one on the left outlines a program that correlates to apples to letters. That's the one we're going to do. One on the right. So, okay, so I probably want to hide turtle after it drops. Okay. So I want to do apple.hide turtle. Fine. After I drop it, I should do that. Fine. Okay, so now they have this big old program to look at. Oh, wait. Oh, because I was messing with things before. It's kind of neat that it saves that. I thought it didn't, but it's probably because I'm logged in. That's good, though. All right. Oh, yay. This looks fun. In each of the programs, okay, so I'm hoping it walks me through this. In each of the programs outlined above, you have been provided with an example of how to use the range function. Read the description in the code and search the internet. How does range work? I don't know. Just look on the internet. Oh, it's right here. Okay. So here's how range works. Range actually creates a list of numbers. I don't know why they say sequence. We should keep our language the same. It's a list. It's a list of numbers. If you say range 10, it'll create numbers from 1 through 9. Notice there's 10 numbers in there, but it goes from 0 through 9. So that's nice. Like if you want to make you'll see some uses later. You can also call the range as 2 arguments in here, 2 to 5. Now, what happens is it'll start at the left number and it'll stop before the right number. So if you say 2 to 5, it's going to do 2, 3, 4, and not 5. So this is going to be useful. I think the best use is when you use like looping. You know how we did this like I equals 0 while I is less than 10, I equals I plus 1. And we did a lot of while loops this way. Instead of doing this 3-line thing, we can just do this for loop. This will behave in the exact same way as that while loop sequence, but it only needs 1 line. I think this is a better way to go because it's a little cleaner with 1 line. All the information you just write in 1 line. The problem with this is you start making extra variables. You get extra lines. What if you delete something accidentally or you don't put the I equals I plus 1 in the right place? You get a larger amount of code and then you delete it and you get errors later. Especially with bigger projects, you want to kind of eliminate that. So it's more efficient to write it this way. For this for loop, I would keep that. I would try to do that. Build the code necessary to create a list of the letters from the home row of the keyboard. Okay. Code necessary to create a list of all the letters from the home row of the keyboard or the entire alphabet. Using the pop function combined with randint to retrieve random letters from the list as needed. Oh, so they're kind of telling me what to. You know what the problem is here? Is it like gives you this, but am I supposed to do this now or am I supposed to follow? Like, I don't know what I'm supposed to follow when I'm doing this. I think now that your Apple resets, it's time to add code to check to see if the letter the user's typed is actually letter. Okay, so it's like they're setting this up, but then you're doing different parts. I wish I had to-dos. So create a function that takes the turtle as a parameter and gives the turtle a new location in the tree. Only if the list of letters is not empty. Okay, associate the turtle with the letter selected at random. I'm going to pause. All right, I've been looking at this for a while. And it's been frustrating me. And I think I figured out why. So, looked at teacher examples. They give us the cheat sheet up here. Give all sorts of stuff about what you do. But, like, we don't need to go over those. But, like, okay. A few things that don't make sense to me. That I just didn't know what they want here. So, I'm going to walk through of what I think they want to finish out this video. And we'll do part 2 tomorrow. So, okay. I'm going to correlate apples to letter, and I use this. Now, the problem with this code, and I pulled it up right here, is this doesn't, they say, oh, there's supposed to be stuff that you used over here, but it doesn't quite match up because there's like no setup area and everything's in a weird order. Like you create functions up here, but you also create functions down here. The Keypress is right here. Why are there functions down here and up here? I don't know. And this for loop. Now, I looked up the answers. I don't see this for loop being used anywhere. Not that way. With this number of apples variable. So it confuses me. So instead of staying confused, I'm going to write down what I have to do. So let's talk about like what the point of this is, right? At this point, we've created something. An apple has an A on it. When you hit the A, it falls. And that's all we want right now. Now, what are the goals of this program? I think what the goals of the program eventually are to change the letter. And so it's the goal. Let's look at what it says. Oops. I don't want to look at that. You didn't see enough anyways. So we want to add some randomness here. So let's write down some of our goals. We want to add random letters. So I'm going to say add random letters to apples. That's one goal. I'm just going to write these on my screen as we go by. So I do want to be able to change it to a random letter every time it appears. I think what I want it to be able to do, so it says, we're going to write down. For the rest of the activity, larger portions, you've seen the random it generate random letters. After an apple falls in the tree, you'll need to reposition it and give it a new letter. So, okay. So add random letters, okay. Reposition apple after it falls. Add random letters to the apples. Let's say add random position to apples. So we want to change it to a random spot. So I'm writing down everything I have to do. And I'm going to keep building this task, right? This is my task list right here. So we're going to do this one step at a time. I probably am not going to do it their way because I don't think that's a good way to show this to you. But I don't know. I can't find it. To help you keep your thoughts organized, this doesn't help me. I don't know. You people that have different teachers, your teachers use this list? Like, this is the part that just got me stuck trying to follow their rules. Because I want to follow, like everything else, I just follow the rules. And I follow how they're doing things, and it's all fine. And all of a sudden, it's the first time, it's like, what? Okay, I explained range. Okay, so the range function is going to be used, blah, blah, blah. Okay, we got this. Build the code necessary to create a list of all the letters from the home row of the keyboard. And use the pop function to combine with random to receive letters. Whoa. So, to come through your code and update anything necessary, draw a random letter instead of the letter A. Okay. Where they say that we're going to have to use the pop function, I don't know if I'm doing it that way. In fact, I think their point of doing this is that you don't use every use every letter once in the list. I don't want that. I just want a random list of letters, and then it just picks randomly from that list. Why would I want to go through a list like that? I mean, you can. That's a different game. Record your plan for resetting after this falls. So when reposition the apple after it falls, a random position for the apple, and add random letters to the apples. Okay. And then so there's a note here as part of that, and it's going to be make a list of random letters. Okay, so to make the list of random letters, whether you want it to be every letter in the alphabet, maybe you start off small. Start off with like ASDF. I'm going to put that note here. ASDF. That's probably where I'm going to start off. Just 4 things, right? That should be good for the start. To access, and okay, so I have to use random in here. That's fine, okay. So that step, I don't know, this is going to be 15-ish. 15-ish around, right? Now that your apple resets, it's time to add code to check to see if the letter the user typed is actually the letter on or associated with the apple. To this, you may need to modify existing functions. Okay. Okay, so you need to make sure a random letter associated with Keypress to drop it. So I'm going to say that's like step 16-ish. Okay. So when we drop it, okay, not just reposition the letter after it falls. I want to make sure that the new position, the new letter, is associated with the key press. I've seen their answers for that. I think I would do this differently. Do this, may need to modify existing functions, create new functions. Okay, so it's all up to you. So I looked at their example. They do it one way, but I'm going to do it a different way. I think you all would. So I'm going to have to do that. All right. Now, when I get to step 17, I'm just going to go way ahead to get ready for this video. Okay, so this is like only doing one apple. So this would be a game above. I have one apple, it drops. And then a different spot, and then a different letter each time. One apple on the screen. All right? But we can make this a game where there are multiple apples on the screen and letters to choose from. In the Apple Avalanche game, the program will need to maintain lists of letters and turtles so that it knows which letters had been typed and be able to accurately drop the right apples. Okay, more important if you choose to link apples to letters earlier. Okay, for this tree, portion the activity, review lists, lists of turtles. So, okay, I think I'll need a turtle list if you use multiple apples. So if we're using multiple apples, I think at that part, that's what we're adding in 17. And record, okay, well, duh, that's an index error. Okay, whatever. Practice iterating over a list of turtles by modifying the code. Okay, so I think we're going to be doing this over a list. When working with lists, be helpful to find out. If you don't care about this, skip this part of the video. Okay, so we're going to generate, to complete this, generate 4 random numbers between 1 and 4. Okay. So we're going to have a list, and then we're going to finish. Okay, so what's finishing? So far, you've learned to add images and key presses to the program using the library. You're at a point where necessary tools complete it. Using your knowledge tools, plan the remainder of the code. Okay. Here's what I was looking for. 21. Code should include the following features. Okay, this is going to be in 21. Up to 5 apples. Okay. Each apple contains a different letter. Apple, different letter. I'm not doing the display 5 on top. When the user types a letter, only the apple containing the letter drops from the tree. Okay, that's implied. Okay. Okay, good. On that, okay. So, if you chose to display letters at the top of the screen rather than the apples, it doesn't matter here which apple drops. Record your plan. And add commented function headers. When you have added all the function headers, complete your program. When the user types letter, only the apple containing the corresponding letter choose to display. Okay, so I thought, okay, so this is like 5 apples, and then you hit them all and you're done. Does a new one appear every time? I don't know. These seem like they're different games. Maybe I was thinking about this differently. Maybe my brain was going somewhere else. So what I do want to next time is I will make it so that the apple repositions when it falls. We're going to make this game. I almost feel like this game is different, but maybe not. So I'll put 5 apples on the screen. I guess that's if you had enough letters. But if you only had 5 letters, that'd be easy. Just keep smashing those. Let's do this way next time. I'm going to make it so there's 1 apple, random letters on the screen. Boop, 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 boop. Do it your way. And that's it. And then why don't we even have the pair? We don't even, I guess you can use it for funsies. Okay. So that's what we're going to do next time. All right. How am I going to teach this? We'll find out tomorrow. See ya.